This question is given in GATE 2014. Let me read it out for you. A FAT file allocation table based file system is being used and the total overhead of each entry in the FAT is 4 bytes in size. Given a 100 into 10 power 6 bytes disk on which file system is stored and the data block size is 10 power 3 bytes, the maximum size of a file that can be stored on disk in units of 10 power 6 bytes is. Now they are saying that how many let's see, they are saying that the total hard disk capacity is some 100 into 10 power 6, the total size, it is 100 into 10 power 6 bytes, right? And now some part of the hard disk will itself be consumed by the FAT table, file allocation table, right? See, initially this file allocation table should always be present in the hard disk, and whenever we need it we are going to fetch it into the main memory. So while booting up the system we are going to get the FAT into the main memory, and anyway you have to maintain a copy of it in the hard disk as well for permanent storage. Got it? Okay, now some space is going to be taken by the FAT allocation table. Now how much space will be taken by the FAT allocation table? That depends on the let us say FAT size. File allocation table size is equal to number of entries in this table into size of each entry, right? Now we have to find out what is the number of entries in this FAT. So in order to find out the number of entries in the FAT, you have to find out how many blocks will be present in the FAT, right? Now if the size of each block is 10 power 3 bytes, right? If the size of each it is 10 power 3, then the number of blocks is going to be total size of the hard disk divided by size of the block, right? Now what is the size of each entry? The size of each entry is given as, and the overhead, yes, overhead of each entry is given as 4 bytes. So this is the total size which is going to be consumed by the FAT. Now if you observe this size, this is going to be 0.4 into 10 power 6. I am trying to write it in terms of 10 power 6 only, right? Now see this, the total size of the hard disk is 100 into 10 power 6 and the size taken up by the FAT table is 0.4 into 10 power 6. Therefore, how much space will be available for a file to be present? Even if a file is very big, it is going to take up this entire space. It cannot go beyond this space available, right? Now what is the free space available after allocating the file space for FAT? It is nothing but 100 into total, the free space available will be equal to the total size of the hard disk minus the size or the space consumed by the FAT table. So this is going to be 99.6 into 10 power 6 bytes. So this is the total size of the total size that the files can occupy. It is 99.6 into 10 power 6 bytes, right? That is the answer. So they are asking in terms of the 10 power 6 bytes, therefore the answer is going to be 99.6 in 10 power, because they have already given it as 10 power 6 bytes. So the answer is 99.6 bytes. Okay.